Hello, class. The second recorded lecture on section 3.2, and this one is going to talk about calculation of standard deviation, which you'll see that when we start looking at these different distributions, that the calculation of the mean and standard deviation are the two most important parameters when you describe these different distributions and equations with regards to how they are modeled. And so the good news is that once you have the variance, the standard deviation is just the square root of the variance. So basically the definitions of the square root of the variance is once you calculate the variance, you just take the square root. So if you think about the equation that we originally had, right? And I'm going to talk about sample again, because that's the one used by far the most. Let's try that again. There we go. So you remember we had the sample variance look like this, right? It was the summation of xi minus the mean squared divided by n minus 1. So one thing with regards to this idea of a square, what the square does is actually artificially increase the value, but it also makes everything positive. So to counteract the square, right, the standard deviation would be the square root of all that. So that's what we mean by a standard deviation. And I think I used the wrong letter here. In the book, this is the sample, which is S, and this standard deviation implies population standard deviation. And so again, the only difference is this equation would be, and they use mu, right? Xi minus mu squared, and then you divide by the total number of data points in the population, which would be n. So that would be the difference between the two. Again, this one is by far the one that is used most often and is by far the most important. And when n is reasonably big, these two are exactly the same number. So when you do this calculation, you basically just do the variance and take the square root. So if you remember when we were in the previous recorded lecture, I downloaded data from the first homework problem in Alex in section 3.2, and we calculated the variance. And so this is, again, let me see if I can make this a little bit bigger. There you go. And so this is calculating the variance, which you've already done. So the beauty of this is once the variance is calculated, the standard deviation is just the square root of the variance. And so how do you do that in the Excel? So again, equal sign to start an equation. What I do as more of a mathematician is I'll use that, remember the square root is to the 1/2 power. So I'll highlight that number and hit Shift F6 again, the little caret. And then instead of squaring, which would be 2, I would take it to the 1/2 power. And so you can see it's a little bit over 8. And that makes sense, right? Because 8 times 8 is 64. And that's real close to 65. So it should be a little bit bigger than 8. So I do want to point out that the beauty of Excel is that the standard deviation calculation is an important one, and they have built-in functions for that. So let me show you this up here. So when we go up here and do the standard deviation calculations, you hit more functions, and you just type in up here, search, standard deviation. And you hit go, and you'll see there's a bunch of them here, and you go down here. And so the two that you will want to use is there's one that says standard stdev.p, and that implies that you have data that's the population. And .s implies you have the sample. So in this case, you could use either one of those depending on what kind of data set that you have. So let's use the S. So you click on that, and obviously you have to be in the cell to get the number, and then you click OK. And again, the same strategy. You highlight all the data points that you want the calculation to do, just like we did in average, right? So we'll highlight that, hit OK, and you can see we get the exact same number. And so the good news is that that's how I would do it, but it's important to understand the math behind it. So say like you wanted to do the variance, I would just calculate the standard deviation and then square that number to get the variance. So I'm going to talk about one more thing, and I need to pull up the spreadsheet. I thought I had it up, but I don't. Let me pull it up real quick. Okay, so the last part is to talk about calculating standard deviation. Personally, I would calculate that first and then find the variance by squaring it, unless you're dealing with the different calculations by hand or using the spreadsheet in the different columns. And in this case, we will need to do that, because what I'm going to show you to do now is calculate a standard deviation given we have a group data, like we talked about in section 3.1, where we calculated the mean of group data. And this is the idea of calculating midpoint, and then using the midpoint as the data set, right? And walking through the calculations, assuming that the midpoint is the data set for all the frequencies. And so the book has an outline of the different steps. And so we've already done a couple of these, right? Compute the midpoint and then compute the mean. And so we've showed you that in section 3.1. And so now the strategy is that you do the midpoint minus the mean. So the midpoint you can think about as the data set, right? And then what we need to do is we square it, and then you need to add those all together. So not only do you need to, first of all, multiply each one of the square by its frequency, and then after that, you would add all those together. And then depending on if it's a sample or the whole population, you divide by n or n minus 1. And then at the end, to find the standard deviation, you take the square root. So I'm going to show you how to do that in this calculation, because you can see that we've already done that in the last recorded lectures. And so this was the data set of the 40 test scores. So I'm going to make this a sample calculation. So these 40 test scores would be the sample of, say, all the statistics students in Waubonsie. And so we calculated the midpoint, and then we have this midpoint times frequency, and then this is our mean, right? So our mean is 73. Why did I erase that? I have no idea. So now to continue this, now we know that our mean is 73. The first thing we want to do is the midpoint minus the mean. So we would take 45 and subtract 73, and that would give us minus 28. And so let me see if I can make these numbers a little bit bigger so you can see them better. There we go. And so remember, you could right click and copy, and then highlight, and then paste first is paste formulas. And so it does all the retyping for you, which is really nice. So the next thing we want to do is square. So what we'll do is we'll take this column, so, or that cell point, so this would be equals minus 28, then shift 6, when you square it, it's 2, and 28 minus 28 squared, everything turns positive. So here's the other next column, which again is a little different because we need to use the frequency numbers, because you see that this minus 28, or as you can see when we square it, the 784 occurs 3 times. So you have to add that 3 times. So just like we multiplied here, we're going to multiply the square term. So this is frequency times the square. So this would be equals 784 times this frequency, which is 3. Highlight both those cells, and then we could do the copy and paste. Whoops, that's not what I wanted to do. Start over. Right click, copy, highlight, paste. There we go. So now that is the frequency. So let's go back here real quick and make sure that I outline these steps. So we did this in section 3.1. So the first column I put up was the midpoint minus the mean. The next column that I just did was squaring that to make everything positive. And then the next column was taking that number and multiplying by its associated frequency. And so now all we need to do is add all these together and then divide by n minus 1, and that will be the variance. And then if you take the square root of the variance, we will get standard deviation. So the next step here is adding all these together using the sum. So now the variance will be the sum divided by n minus 1. And so the frequency is 40, so there's 40 data points. So you could do 40 minus 1, or you could do this one in your head, right, and just divide by 39. And then the standard deviation would be the square root of the variance. So again, you hit equal sign to get started, highlight the variance, and then you take it to the shift 6 to the 0.5 is the square root. And you can see that the standard deviation for this would be 14.7. And the mean is 73, and then the standard deviation is 14.7. So sometimes data is set up this way. So it's nice to understand how to do this calculation. You'll see that there's only one problem. I believe the last problem in this section deals with this type of calculation that you can walk through. But the most important concept is this standard deviation. And the next, and tied for the most important, will be the lecture that I will do next, which will talk about the empirical rules of mean and standard deviation, given that it's a normal distribution.